use your data, right? Just actually go out and use the data itself. Don't let some fear keep you from being able to actually go out and make some decisions and put the right people on it and start to take a look at what's out there, because we have more opportunities now than we've ever had with the tools and the technologies that we have. So it's a great space for us to be working in.
Yeah, and my closing thoughts were, we have been at it for a couple of decades now in an accelerated phase because of the availability of big data, giving strength to the age-old statistical techniques which can make decision automation a possibility reality. We are at a point right now where the human impact of all these changes is quite profound. The cost to, if it continues without any checks and balances in the system, the cost is very high. So this is a good time to take a pause to understand how can we do it responsibly. And responsibly is understanding, being aware of what issues are there, and then how to mitigate it. There are smart people, once they know the problem, they can solve the problem. It's about us to know the problem in the first instance.
Yeah, this is when it's hard, because for me it's about two things. Use what you've got, so it kind of goes back to it. Match it up with youngsters. One of the things I have learned, and I think you said this, we've got this rock star, folks who are coming out of colleges, which they think completely tangential, and they bring out new models to support the next wave. Use what you've got, fund innovation, take the risk of betting big on some of these. I think that's probably the only advice I think we live by, but I think I can also give. Support the next wave and bet big. There's some good stuff that's going to come out of this. Whether we know the answers to it or not, will play itself out.
Yeah, 60% of the time it always works, right? And so, what ways could you fail, and how much would being wrong cost you? Those are things, we always want to have high predictive power, but what if you get the wrong answer? And in healthcare data, you can take any of the grand results from AI that you've seen. When you apply it to data, you could reduce the accuracy by a third to a half almost. And at least in healthcare, being wrong is a much worse mistake than being right is rewarding. And so think about ways that your project could fail. What would be the most costly areas to be wrong, and look for the bias in those areas first.
From at least the healthcare point of view, one of the aspects we see a lot is what essentially buckets into sample bias, which where is the data coming from and what kind of a demographic does that represent? A lot of the data sets that you do can see, one of the examples I have is, we've got something called the Framingham Heart Study, which is out in Framingham community. If you look at, it's one of the best resources for data that has been collected multi-generationally over the last 70 plus years within families and their successors. But when you look at the community, it's predominantly white Caucasian, predominantly male in a certain age group that sort of are part of it. So one of the aspects which again goes back to how's the data being collected and what's your sample, and we sort of deal with that a whole lot, especially when you start mashing it up and linking it with other data sets, disease burden data sets. The second one is what I call prejudice based within those data sets itself, and the third one, which I think you started going towards, is how accurate is the data that is being collected, because this really compounds the value of the data that sort of comes into a central clearinghouse in the first place. On top of it, if you're going to deal with AI and you're going to have machine learning models that are going to start establishing linkages between those data sets to drive an outcome, it then you start really seeing it in forms of results. And I'll give you a simple example, at least from some of the vantage points of what we've seen. Is I was telling this to Daniel, that we were doing, there's this research study that's already out there which says that if you are pneumonia is good for you for stroke and cardiovascular disease. And that's, when you see that result and you're like, how did that happen, right? And what was missed was that the model couldn't train itself, because you see sort of, if you're a pneumonia person, or if you suffer from COPD and you go into the ER, they're gonna automatically take you and put you into the ICU, and once you're in the ICU, you're gonna get the best treatment from the best staff to actually preserve your life. But and you start seeing that establishment of a deep learning model connection that happens at a level which is very difficult to predict because of these kind of associations. But anyway, sample bias, prejudice within that, and then underneath that, the accuracy of the data. All three compound itself into some associations which need validation and verification, which is part of the process.
Yeah, and that's, the reason why all of this is important is really you're concerned about, is there something in the data that can make your inference or your characterization, your modeling systematically wrong, and wrong in ways that are not favorable, right? And so part of it is still taking a kind of like we talked about before, it takes some humans to think about this. There's a really interesting podcast, if you want to listen to it, called The Hidden Brain, about how your own bias influences the decisions that we make every day, the products we buy, the ways that we think about the world. And remember, data is created by these same humans with a built-in bias, and so it's something that we constantly have to think about during the stage when we're thinking about how in the world could this answer possibly be wrong, incorrect, or misleading.
Just to add to that, a model is nothing but an abstraction of reality, right? So if I have my reality with my blinders on, that's the only reality I'm going to look at. If my blinders are open, maybe I don't have processing power to connect all of the reality. So it's about figuring out how do I sample so that I have a representative from all of the population correctly included in my input data, so that my abstraction of reality reflects what is out there and is applicable to majority of the population. Again, I have a bias on the majority here while I'm saying this, so it's important for ensuring that the bias is most difficult when it hits people, right? Like if it marginalizes people, or if it makes a decision in which there are human consequences. If there is a network that is not getting power just because I had some bias in the sample that I've taken, I think the consequences are not that comparable to when a part section of humanity is affected. So that's what being cognizant of the impact of first, understanding where the bias is coming from, of course, being aware of it, and being cognizant of the impact of it is much more important as well.
I'll add. We're just going to keep going on one question, so that's okay. One of the other things is just looking at the size of the data sets, not just the selection of the data sets, right, but the size of the data sets themselves. Sometimes we just have simply a small amount of data, and that creates some huge biases, right? On the opposite side, nowadays we have more data than we know what to do with, and picking what data we need to look at and how we need to look at it makes a big difference in that bias as well. So we can create some biases just by the data that we choose or the amount of data that we're working with.
Well, I mean, you definitely touched on this really interesting concept of we've had bias in our data for generations and generations, and we know it's there, we know how to deal with it. Why do we still have bias when we're collecting the data in test subjects? Why does that bias still exist? And how can we potentially get away from it? We're designing the experiments. We should not have bias if we're designing those experiments.
But we're still human, so there's still human interaction in the data that we're looking at. And even if we bring it in through, let's say, devices, right, Internet of Things devices, it's scary working, right? There is still a person who's looking at the data as it comes in to hopefully help cleanse the data, because we talked about data not being clean, and that causes huge biases. But when you put a person in touch with that, right, that does cause some changes. To your point earlier, though, you put a machine in front of that too, and it's got its own set of biases, right? It's using the information that it has it can't distinguish necessarily certain rules or certain aspects that a human can. So regardless, we're not going to get away from the human side of it. I hope not anyway, because then I think we're all out of a job. But the hope is that we think through that, right? That there are always people touching the data, and when you touch the data, that causes a huge amount of bias.
Again, human biases, we are a great system of data exhaust. So we are the reason that the data exists, right? Like out there, we create a lot of transactions processes. So when we make processes, those data exhausts that we create also carries the traces of biases we have, interactions of biases we have. So that's one easy entry point for the bias. The other points are when we select the data for analysis. When we select that data, we probably are, as and when we can select a part of it, we are kind of focusing on certain area because of the ability to churn the data, to kind of understand the data. And then in that sampling, there is a huge bias that can probably come in. Right. If you understood how there was that Truman versus Dewey kind of presidential election thing back in 1948, it was basically because they sampled people over phone, and only rich people had phones back then, and they realized that rich people favored a guy who didn't win at the end. So it kind of happens because unconsciously the sampling areas and the sampling reasons we selected kind of induce us or expose us into some kind of biases. Being cognitive about it is what we can do, and being aware of it is the first step towards eliminating those biases from the sampling. Useful, basically, kind of difference between the cause and the effect, right? Like, if you have an effect that you can monetize on, then you will. If you have data that causes that effect, you can always train an algorithm to kind of monetize that entire piece. However, I think the bias in the data only makes that algorithm, because it's looking at a portion of reality. If you just give it without accurate sampling, if you just give it without consideration for some kind of oversight on which are the risky elements it is touching, then we are actually training the algorithm to make decisions, because it's as far as we call it artificial intelligence, but it's just a huge bit of code, right? That it's self-generated. So what it understands is between thresholds. If it is this variable is between these thresholds, etc. So if we give it right kind of variables, if we curate the information that is going to the algorithm, we have a better chance. And if we are also aware of the biases that can be advertently or inadvertently we introduce into the data, we have a better chance of curating the entire outcome as well, so that it is not too sensitive for people, and bias is not immediately recognizable.
Let me take bias out for a second and just talk about making the data useful, because a big part of it is putting it in the hands of the right people so that they can make decisions based on the data. And what I've seen as I've worked across a lot of companies is a lot of companies are really great at building reports that they never look at. But what we need to get to is the point of having a group of people who really do look at the data from a business perspective and make decisions based on that data. Now, there will be bias in some of that data by the person, by the data itself, but a lot of companies haven't gotten to that point yet, that they have these groups of individuals that really start to look at the data and have what we consider to be a passion for the data, right? Finding better ways to do things within the organization or within the healthcare company or whatever it happens to be, right? And I think when we find those people and we change the way they look at data, they're not really building reports anymore. They're really looking at the data to make better decisions. I've worked with companies where we put together groups of people that are some of the best business people, that are really the people that can't keep their hands off of a spreadsheet, and you know these guys, right? They're always playing with the data. I don't care what position you have them in. If you can pull them away from their day-to-day job and really have them work with the data. We've done it where we put them together and had them report to the steering committee with with decision, with looking at the data and saying, here are ways that we can reduce cost, increase profit, have more customers, right? Whatever that happens to be. And suddenly they start to look at data a different way, right? They're now not looking at data as a report that I would have to build, or some number that I have to find on a report, or even some algorithm that I'm doing. It's really looking at the data to make better decisions, and I think that's a big part of the usefulness of data, even aside from the bias that you might see.
Great tools out there, and many vendors are coming out with more and more tools that we can use large amounts of data put into them. Well, those tools, as you're using them, can't those tools help us prevent bias in our resulting models?
No.
Why not?
And we're seeing a lot of these tools, especially tools around sort of automating data science. And I've never spent so much energy before in my life than trying to stop what I call self-assisted suicide in the organization. Because what happens is these tools are adopted by people who have not thought about the data. The data is just there, right? After all, we'll put it in a deep learning model and it'll figure out what the right answer is, right? And then all we have to do is click the top model and deploy, and suddenly we've made $17 million more profit. And nothing in the world can be farther from the truth. Just this week, Google announced a new cloud-based AutoML that takes the whole sequence of data. You put data in your BigQuery store, you run AutoML on it, and it will automatically find just miraculous and wondrous things. This is still dealing with data that has bias because your sensor broke, because somebody entered or reloaded a database, and now you have duplicate measures, and one of your variables, predictive variables, is now overly weighted because it has twice as many observations. It has zip code data, which is a proxy for race, socioeconomic status, and whole kinds of stuff. And now those tools are making it easier for the bias that exists in the data to actually make it into our business decisions and processes. And that is really should be a frightful thing for any sort of data organization, because the advent of sort of one-click, easy deployment of analytic insights is still one-click deployment of data and everything that can go wrong with that. And so it will continue to get more popular until somebody makes just a stunning example of themselves as a gigantic failure of how to automatically deploy a model with biased data that will be talked about in grad school programs for years to come. And then people will be somewhat less enthusiastic about it. But those kinds of, just kind of like we said earlier, just because a tool is available or even used very, very often doesn't necessarily mean it gets you the right decisions. Machines only answer the questions that the humans ask of it.
Remember that I worked with 23-year-olds, right? And I will tell you that they love the technology and they love building the models, and they'll keep using different models until they get the answer that they want, right? This is how some people work, right? So it's not necessarily the right answer, it's just trying to work the model. And I spend the majority of my time trying to get them to step away from the model for a second and tell me, so what? Right? You ran this great model, it looks lovely, there's great code here, what does that tell you, right? And I think the tools don't help you interpret necessarily all of the results. You really have to have some thought, some business mindset as to what the tools are telling you in the first place.
Microsoft's got a framework that came out I think last year. Watson team and IBM I think have a similar framework. I think next time, there's several of them out there. Amazon's now releasing a whole bunch. We are hopeful, but it's supervised, learning models I think is the way to treat some of these. They do need a little bit of supervision. Hopefully they do augment, so we're quite hopeful that it will take some of the repetitive work out. For those of you who work in sort of machine learning, and you've got supervised learning, unsupervised, especially when you start dealing with transfer learning models and
we start dealing with neural networks that actually start making these deep associations, it can get crazy, and it's very difficult to actually find in a neural network where the association was made that resulted in an output that kind of bubbles up in terms of a decision making. And again, there's no supervised learning is probably in the short term the way to go, but these companies are doing some phenomenal work, and we're cautiously optimistic, maybe.
Sources of data bias, right? You mentioned there's hundreds, even time, the data set. But what we actually haven't talked about is how mature is the discipline in terms of how you evaluate what you're doing? Are the repeatable, thoughtful steps that help you evaluate what bias may be there? So if you're in a retail company and your customers are low economic, demographically based, in a certain cultural background, by definition, your market has a certain cultural bias, right, or economic bias. But so how do you systematically go back and look at the data to say, is there a bias or not, or what do I need to correct?
You can actually start with, yeah, it's a great question, to understand. And this is the whole focus of AI accountability or ethics of AI, which International Standards Organization has just started looking into. Maybe they are 5 years out, or some more than that. So one easy thing that we can do as of now is looking at variables. Let us understand how algorithms think. They think in terms of dissecting variables, right? So they understand thresholds and when they can maximize the impact. That's how, based on your objective function. So there are two times you can do it. One, you look at variables which are providing us for the algorithm to digest. If you have alternatives, then a very focused sample, like let's say you have a race as an input to the model. If there are alternatives to that without actually indicating race, try to consider them. This is what we can do at the moment. Or second, I think, I'm just dreaming right now, but all objective functions either maximize or minimize certain things that are important for the algorithm. Maybe we can add, if we can quantify bias in a certain way, we can add that to the objective function to reduce the bias as much as possible. But this is the most of the research field that is going on right now. But yeah, great question. If we look at variables that we are providing for data, we can kind of escape it. And there are other too, maybe.
Right, because if you are talking about certain types of stores where a certain demographic of people tend to go to that store, then even though it's biased based on the whole population, it may not be biased based on that type of store or that type of location, right? So it's just something else to consider too, because it may not be a negative thing always.
Yeah, going to public policy, I think where that gets tricky is when somebody gets declined, let's say it's a loan, gets declined a loan because they don't fit the bias demographic.
Brooks.
And so someone sues because they didn't get it, right?
So part of what's interesting about that, right, is the long-term effects when you start to use artificial intelligence opposed to just dashboard analytics, where that works great for the day-to-day business until you get somebody outside that demographic that sues them because they didn't get the loan, right? So how did you make that decision, and why was that appropriate? And so I think that's also where it gets very complicated in a retail or consumer environment, right? Is determining what's acceptable and how much risk you accept.
One thing is these biases did exist earlier as well, right? But however, I think it's a human tendency. We have seen hammers working right every single time we use them. So we tend to think that these machines have to be right almost all the time. And we are biased towards kind of machines as well. So we should, I'm not saying we should give them a limited amount of freedom, but we should understand that they are machines as well. And whatever decisions humans might have made, they were mistakes as well. Probably they were not as much magnified as now we are putting the car under the automated car under a huge magnifying lens. Probably.
Thanks, I was reading an article recently about the developers of a new search technique back in 2007, where they were saying that Google wasn't at that time interested, and that Google basically goes out and finds data
related to whatever topic you put in the search, and find this and that and that and that, brings it back and gives you 8 or 10 options. They worked on a solution that is becoming more and more preeminent now in the mobile world, where I want you to go out and find the right answer to my question and just give me that one. What do you think about data bias in terms of that modern search environment, trying to bring back the correct answer with only one option, where you don't have the human ability to go look at those links and say, I think that one's the one I want?
So we're going to go ahead and assume that it interpreted your question correctly and completely, and that's about a 3-month discussion. If I was building a company like that, there's no way in the world I would do that. Simply because I would have to know for certain that I interpreted the question completely and correctly, and that the intent, which is really hard to uncover, was correct, and I gave you the one thing that was most important to you, rather than your most likely things that you may or may not know that you're interested in.
That company was acquired, and it is now the Google Echo.
Which is why I sent mine back.
I'm just going to take it back to the use case and just say, the intent of the outcome is probably where it falls on. If your intent is to, let's say, win a chess game, then that one answer based on the placement of the pawns, as long as you can pass it back, so again, it just depends on the intent. It's going to be real hard to have a one single answer. I keep going back to that all bias is not a bad bias, but it can be interpreted, and there's some great commercial models that are available for bad bias models.
And unfortunately, we are approaching our hard limit on our time, so this will be our last question.
Okay, I'll try to make it good. Earlier, you mentioned making comparisons between different models, which starts to sound like having a control group in the medical field versus with the placebo versus the actual medicated group. Is there anything like that being done with, for want of a better term, clean data sets that industries might adopt and then put through whatever your artificial intelligence process is to try and identify biases or outcomes that would be unexpected from that data set?
Yeah, there actually is. There's actually work, there's been a little bit of work from the University of North Carolina State on finding bias in your model outcomes. Now there's a couple of technical requirements for that, but I thought it was really good just to make an initial attempt at tackling the problem. And it looks at sort of the distribution of things that come out of the model and things like that, not necessarily with the variables that go into it. But is your model systematically choosing one way or the other? And so there has been, and just in the academic world, some thought to go into that. There are some what I would call still experimental ways. There are still that I know of methods that you can put it through that go beyond the human asking the question. Prove to me, or making a statement, prove to me that your model is not wrong. And I think if we just think about that will lead us down to ways in which the data could be biasing our model in different ways, and thinking about the ways to look at negative bias, because in some cases bias is simply called market segmentation. And so what the wrong answer is sort of context dependent in a lot of ways.
I'll probably give you what I think comes to my mind within the healthcare life sciences groups. So there's essentially what I think is of these honest broker conveners, and I think we as AHA also think that the role to play. Many other sister organizations and universities and academic centers fall in that category. It's essentially being the honest broker between different parties who normally wouldn't talk to each other, but they'll talk because there are two parties involved. some of the groups that have been doing some great work, there's a Global Alliance for Human and Health, I believe it's called. They're doing some great work. There's, we ourselves are part of what is essentially called Joint Commission, which is ACC, HA, Diabetes. There are groups that are all automatically kind of coming together. Doesn't mean that others shouldn't, but I think there are some novel networks already working on it. Are they coordinated? Can they be better? I think that'll automatically come. I think that's I don't know if you really need a holistic central agency to drive all of that, because that's going to probably impede some of the innovation that sort of comes out of it. So I don't know, I'm curious to know what the others are saying.
If I interpret your question right now, you're asking, is there a way we can clean data before the models use that?
That would be a requirement, right? That would be using clean data however you go.
My group in Ericsson, we started about 5 years back. We focus on how to make data science more practical. We were a little ahead of the maturity curve to say that, okay, we need the data together, and then we need to build use cases on top of it and make it practical, so that we focus on operational efficiency, kind of where are areas where we can actually have machine in the loop with human-assisted AI, and then push the thought a little forward so that we can take cost off. And then it also eventually became evident that this is such a powerful technology. We also need to use it in products. So we started another group which is focusing on making our products more efficient and those kinds of stuff. So today the focus is actually bias in data, and I want to spend more time on discussing that and getting to you and kind of form a base for understanding. We are all biased, to a certain extent. It seems there are about 100 different types of biases we have, and all are logged, all of them. And the interactions between those biases make us much more complex beings, actually. So whenever we make a transaction in the overall space, we are sending all these data samples out there in the space, right? Now, it's okay till data stays there, but nowadays what we are trying to do is look at the log of the data and trying to make decisions over it. So when we are making decisions over it, whether it is human-driven decisions or AI-driven decisions, AI is just a complex math formula, right? It's essentially a regurgitation of this data. So when we are making those decisions, the impact of the data, if there is a small, so if you look at the definition of bias, it's just an unjustness or some kind of prejudice in how it works. So if you look at that, it kind of creates a small discrepancy in the decision making. So it's like left is more than right kind of stuff. What happens with that is once you add more dimensions on top of it, like if it is just there, it's no problem, but it itself becomes a data point. So every decision becomes a data point, and it becomes a cycle. So the data adds to the decision, so the bias gets actually magnified over time. Now it stands there. It used to happen in the human history. We are not the first people being biased or something like that. What happens is, if you add the tenets of big data on top of it, the volume, velocity, veracity, this cycle becomes the rate of this increase that's when the left becomes more left, right becomes more right, or the minority gets more minority, rich gets more rich, and poor gets more poor. So that's what happens when this cycle improves. Now, add on top of it the business models, which are actually becoming more digital in nature, right? So these business models want to use that data, create more division, because the entire AI is the purity. Basically, our entire objective functions we define on the AI top of it looks for purity in the data. So this creates a digital divide, and that's where we are right now. So to create digital divide, to understand. So each part of bias that is happening in the data is becoming so profound in our lives, because when we are going to get a loan, it impacts us. When we are going to get a even legal help, it impacts us. Or any kind of thing that we are trying to do right today. So that's when this bias becomes very important in data, and it's an excellent topic to talk about because the impact is so high. Thank you.
Absolutely. Medical biotech company, but we focus on animals, pets. So every time your dog or cat goes to the vet and they get a blood test or a urine test, we're probably the ones that do it. And it's kind of a unique situation because unlike in human medicine, pets have no diagnosis code. So we have to figure out what's wrong. Now, we also have kind of two unique facets where data is generated in our organization. Obviously, in the testing side, the diagnostics, what happens in the blood test. But we also have a customer-facing software side where we collect the retail point of sale and medical notes for all of those visits. Now, imagine if you had the healthcare information from about 60 to 70% of every healthcare clinic and hospital in the country. And that's kind of the volume of our data. But it's not labeled, has no diagnosis code, just a bunch of results and observations. And so data is always generated by a person, a process, or a sensor. And you can have bias in any one of those. Your sensor can break, your vet tech can enter the information in an unusual way. We just finished, we're working on standardizing some new data. The most common dog breed in America is the Labrador Retriever, right? Pretty common. I bet you didn't know that there is well over 1,000 different ways to say Labrador Retriever in the medical notes. And so we have to figure all of this out. We have to assign reasons for why they came. We have to infer why they came into the clinic because the data doesn't tell us. We have to infer sort of what the doctor is saying. It could be very terse, a lot of abbreviations, one-letter abbreviation, or it could be we were doing some work just this last week, and a veterinarian wrote literally a dissertation on how tramadol is metabolized in a dog's system. That's great, doesn't have anything to do with the dog, right? As this specific patient. So how do we gain insights on individuals? And that's really our goal. It's all in the form of raw data, and our group is the group that sits between data coming in from the outside world and making it useful for the rest of the enterprise, all the way from practice intelligence, trying to help the practices improve their businesses, to investor relations in the C-suite. So there's a lot of people that use our data, and we're the ones that have to kind of figure out and come up with labels and information to turn the data from just data into information.
Awesome, thank you.
So I do direct the Masters of Science in Business Analytics at SMU, but I've been there for 5 years, which is the length of that program because I helped build that program. Before that, I worked for 26 years for Accenture. I was a partner in Accenture. I ran their global SAP analytics practice. So I've been doing analytics for most of my life. I won't tell you how old I am, but at least half of my life. So I love analytics. It's a great thing. Now I'm teaching the next generation of people who are going to be doing analytics. My average age of my students is about 23. So when we think about bias of data, I'm going to take a little different tack from these guys, which is it's also how you interpret the data. And when you put a 23-year-old in front of a data set and have them interpret it, it's very different than a 50-year-old who interprets the same data. So there is also bias in not just the data itself, but also in the insights we gain from the data based on who we are and what we think about the data. We also see some bias that comes in things like working with different tool sets. So today you've seen an influx of tools that are free, open source tools, and there are great communities out there. So we've seen this huge new community of people around Python and R, and if you go out there you can actually see a lot of different models that you can use, most of which have not been tested. But we see them out there, and like our belief in anything that we see on the internet, if it's there, it must be true, and therefore we use it. So there's also some bias that hits on some things like that, not just in the data, but in the models that we use or the way we interpret the data. So hopefully we'll hit on some of that today as well.
So thank you. You at work.
Great. Thank you. It's a pleasure to be here. So thank you for the invitation. Really excited to be here. So I've had the honor and the pleasure of working for the association, been with the association for 5 years, and I am part of what we call the Emerging Strategies and Ventures team that essentially is working with both staff at AHA, our volunteer pool, and the research clinical side, thinking about areas of AHA that these long puck, hockey puck investments that AHA is going to make, both in the field of science, data, technology, and research, to see how we can advance cure for cardiovascular diseases. So I have, within the emerging strategies side, I lead the strategy and planning side for essentially 4 centers that sit within my purview. A Institute for Precision Cardiovascular Medicine, which is primarily focused on trying to bring together different diverse data sets. These are genotypic data sets, phenotypic data sets, which are primarily behavioral data, clinical data registries, and making them searchable, discoverable, and accessible to the research community so that they can do what they do best in terms of extracting insights and value that are that can be eventually be translated in the form of guidelines that are implemented on the grassroots level, or sometimes lead to innovations that can then be taken forward to the industry from a more commercial perspective. The second center is a center for accelerated drug discovery. Most of the work there is focused on trying to create, again, what we call protein atlases, which fuel into creating drug pipelines that are primarily of interest sometimes to the pharma and the biotech companies, but almost all of them have the underlying element of trying to bring together high, deep density data that can then be analyzed through some high impact predictive modeling. We partnered up with Lawrence Livermore Labs to bring in what we essentially call high impact technology matched with high impact science and research from the AHA side. Lawrence Livermore, of course, bringing this notion of supercomputing infrastructure. So it's the next level of high compute infrastructure that you sort of see cloud going towards. Sort of operates at about 100,000 zettaflops when cloud today operates at about 100 zettaflops. So it's really, the larger aim there is to actually reduce drug discovery time to market and reduce it by about half. So it's a big bet. A lot of that work happens within that center. The other 2 centers are more around health tech and innovations, which is primarily aimed towards incubating and creating networks with companies who are coming up with newer innovative solutions that can have implications in healthcare. And last one, which we don't necessarily talk a whole lot about, is it's a venture investment arm. It's called Cardiation Capital. It's aimed at creating early angel investment opportunities to support the community in bringing solutions to life. So that's again an example of us trying to think a little bit outside the box, trying to create public-private partnerships. The larger goal, which I should probably say, and from the AHA point of view, is we are a research.
Is that ever on?
Which one? This one?
Either one. They both work? They both work. Awesome.
Our goal is we are a research-driven organization, and I think for the 93 years that the association's operated, it's always been towards funding science, and it has always been on the element of basic science, clinical science, and population science. I think increasingly in the next decade, we are more focused on trying to straddle this line between science, tech, data, and then using predictive modeling to actually drive and accelerate the results. So for us, and for me, it's about accelerating science using the power of data and technology. We have a huge investment in sort of helping improve the lives of Americans, and as we are increasingly going on the international front, it's the elements of social determinants and raising health equity continue to be about the same in pretty much every economy that we are beginning to get into. But again, I'm happy to talk a little bit more about some of these aspects, but I should take a pause before my hand gets slapped.